Hello, everyone. My name is Matheus Milani, and I'm the product manager for the WatchTower Platform. And in this presentation, I will deep dive on two specific capabilities, alerting sites and the machine learning sites. So starting with a quick overview on the WatchTower. So WatchTower, our observability platform that has this unified interface where you can get the contextual data around the problems that are happening into the ZOS. And you can use that information to quickly identify problems and lead towards a problem resolution. As I mentioned, so we will be focusing on alerting sites and machine learning sites. However, we have other capabilities that are also part of the platform as topology, filing, and the real-time streaming ZRs. So let's start this conversation talking about personas. So the first persona that we like to discuss is Ashton, the level 1 operator. So the level 1 operator, they have a specific challenge, which is to really prioritize all the critical alerts that are happening on the environment. So they needed to look into all those critical alerts, make sure which ones are most important, and they needed to go through all the different tools to make sure that he can not only troubleshoot, but hand over that problem to the next level. So that big challenge is because many of those tools are sitting on different platforms, require different user IDs, different passwords. So the data is not centralized in one single place. So they needed to look into documentation that are sitting outside of the mainframe. They need to execute commands. They needed to look into metrics, logs, and etc. So it is time consuming. So if they had all that information consolidated in one single place, that would be easier for do the problem handover. And talking about problem handover, so when we mention about the operator, the idea is really to do the initial troubleshooting. Some of the operators, they will have the skill and the ability to solve some problems. However, in most of the times, they need to rely on the SMEs, specific by each domains, and hand over the problem to them so they can do the permanent fix or restore any kind of outage. Now, when we think about handing over a problem, we would love all the problems to be solved this way, in a linear way, where the operators, they will identify what's happening in the environment, they will look into their documentation, and then they will gauge the SMEs, and SMEs will solve the problem, and everybody's happy.
Yeah.
However, in real world, in very complex environments, so yes, you will start with the operator looking into critical problems. Yes, they will identify and engage the next level support. However, they may get to the point that he will engage CICS and they will say, it's not me. And then they will engage the DB2 and it's not me. And then it's storage and then ZOS. Then in a blink of an eye, you have a war room full of people trying to get to the resolution and the root cause of the problem. That's where we want to help. We want to simplify the process. Make sure that that data is available, and with that data available, they can quickly see where the root cause is and bring it to the resolution. In order to do that, we are really focusing on what we call the contextual data. The contextual data is where you can get relevant information automatically around those problems that are happening into the ZOS. So you don't spend time hunting that information manually. So we have all the logic behind it, leveraging all those different APIs from our products like OpsMVS, SysView, NetMaster, and make sure that we can bring that information close to the problem so it will be in their hands and their eyes so they can start looking into that. So how we are dealing with all that data that is coming from all those different products of the environment? First, we are leveraging one of the WatchTower capabilities, the alerting sites. Alerting sites, yes, it can consolidate all the alerts in one single place, but it goes beyond just consolidating alerts. So the key differentiator with the alerting sites is to make sure that you can grab all the data around the problems that are happening. So you can get logs, you can get metrics, you can get information that it will be in front of you, and you don't need to hunt that information across different systems and different products. The second part and the second capability is the machine learning insights. So that's our anomaly detection capability. That's when we are looking to specific data and we see when there is an abnormal behavior of the environment. So every time that we see a deviation, we're going to be able to produce an anomaly detection alert. That alert will be forwarded to the alerting sites, and together with the alert, we also carry the metric that will show where the deviation is. So operators or SMEs, they can use that information to identify what's going on in the environment. And for last, we have the infrastructure topology. That's how we auto-discover all the ZOS components that exist on the ZOS environment, and we show the connections between them. So we can really show how a CICS transaction is connected with another transaction, with a DB2 package and plan, with an MQQ, and we can use the topology for the impact analysis. Maybe you are looking to a specific problem or a specific alert, and that alert is not the root cause. Maybe that CICS alert, it is related to another DB2 subsystem, and the problem might be on the DB2. So you can see through the topology how all the different pieces are connected, and you have the 360 view on the entire problem on the environment.
So, question about that. Is there a way to restrict views based on what people are allowed to see? Or if you get a view of the infrastructure topology, you see the entire infrastructure, or can it be restricted to your level or to what you're working on? Or
so today, the access to the topology data, it's open for everyone, so you can go deep as you want. So usually when we are talking about the level 1 operators, they will really stay on the layer about the hierarchical visualization and some initial connections between components. But if you are an SME, then you can go deep and look really to low-level components like transaction files and all of that. But all of them, they will have the same access, so it is accessible by everyone.
And is it just a view accessible, or are they actually able to take actions on that topology?
No, it's view only.
Okay.
Okay, so let's take a look into a demonstration on how the alerting sites, ML sites, and the topology all play together. So when we start this demonstration, please think as an SME that is looking into a problem, or an operator starting from the incident part. So imagine that you have an incident created on a service management tool. So when we are using the ServiceNow as an example here, and then from there, you will drill down into the problem resolution, leveraging all the contextual data that is around. So here in this example, we have an alert related to a CICS under stress. And in this incident, we are carrying over the URL for that specific alert into the alerting sites. So you can get some basic information on that alert and an access to QuickRef. QuickRef is like a dictionary, so you can use that information to understand what the problem is. You have basic information like grouping, severity, who is assigned to the problem. Plus, the first place that you go when you are investigating a problem is the log. So here we can fetch information from the logs from OpsMVS, the ops log or the Opera log, and bring around the problem that is happening. Plus, go ahead.
Were you able to click right from ServiceNow into? Oops,
What did? Just one second. All right. Hold on. I tried to pause. Okay, go ahead, please.
Well, did you have to copy and paste the error number, or were you able to click from ServiceNow into your product?
So WatchTower today has an integration with ServiceNow, so you can create incidents automatically. So when you create an incident automatically, then it carries the URL for that specific alert and with all the details. So when you are inside the incident, you can click there, and then it will take you back to the WatchTower alerting sites, and you can start the investigation.
Okay. Thank you. Sorry to mess up the demo.
No, that's fine. So I think that I just needed to click here.
I'm the worst. I'm the worst.
So what you're trying to resolve is one of the problems in the list of problems, right? You selected one, you're getting information about that problem.
Okay. Exactly.
I'm with you.
So in this example specifically, so the incident that was created is about a CICS problem. So then we're looking into the QuickRef to get information. We are looking into the log because we can get the logs from out of OpsMVS, or using getting the opera log through the sysview API. So all in one single place. So we are using all that contextual data to get to the root cause and correlate with other problems that might be happening on the environment. So besides the log, we can also get information about metrics. So we are using sysview APIs to bring metrics that are related to that specific alert. So here in this example, they are out-of-the-box metrics for CICS specifically. So that helps then with the troubleshooting. And we also give you the ability to customize those metrics and create templates from the different problems that you have on the environment. So in this example here, we have some additional metrics like active tasks, CICS regions, transaction rate that will be related to the problem. On the top of that, you can also use the alerting sites to identify if other problems are happening at the same time for that same specific region. So maybe the alert that you started from the service now, it is just one single alert, but other alerts might be happening. As this example, we saw that there are other alerts related to that CICS region, and in this case, it's an anomaly detection alert. So as you can see, this is the machine learning highway, where we can show what is the deviation related to that anomaly detection. From a topology perspective, you can use all the different connections that exist and were auto-discovered in the environment. So you can see that some specific CICS region has a connected with a DB2 subsystem. From there, you can query other alerts that are related to the other subsystems. So in this case, you started the problem on the CICS, you saw that the CICS region has a connection with the DB2 subsystem. Now you are able to see all the alerts that are open for that DB2 subsystem, and you can start drilling down from there. So as you can see, you go to the main page and you come back, you can get more information about the quick graph, you can get more details around the problem, and you can also add some specific information about procedures that are for your specific customer. So not only quick graph, but also, okay, issue that specific command every time the problem happens. So when you see that, you also have the ability to leverage our command interface inside the alerting sites, and you can issue commands from there, leveraging your authority and authorization into the ZOS, and you get the response in context, and you can use that information to do display commands or take actions. It all depends on the permissions that you have.
Just a quick question, sorry. So you're obviously issuing display commands there, but you could issue just a cancel something, force something, do whatever you want. So yeah, it's read only through the interface, but you could take action by manually issuing the commands.
Yes, exactly. So when you log into the alerting sites and WatchTower, you are using your mainframe credentials.
Yeah.
So we are leveraging all the authorization and permissions that you have under your security product. So if you don't have access to execute a specific cancel command, it will say that you don't have the permission.
Yeah.
But so it will leverage that. So, and as you can see, besides issuing all those commands, we also keep all the history on when they were issued, so who issued the command, the date, the time. So you can use that information not only for audit purposes, but also if you'd like to see which action you took in a problem in the past, you can also use this as a kind of a knowledge database and get more information about it. Now, high-level view of the architecture. So are different parts that compose all the alerting sites and the ML insights architecture. So we start there parts that needs to be installed inside the ZOS. So specifically for the alerting sites, we have one component that is called Alert Central Connector. Alert Central Connector is what make that interface between the products and the data that will flow into the alerting sites. So it will really make that bidirectional communication. We are leveraging APIs. So as also part of these components that are installed inside the ZOS, we have the Zoe API mediation layer that is our API gateway. So it will be responsible to manage all the different APIs coming from all these different products. And also it is used for all the authorization and authentication into our platform, because as I mentioned, we can use our mainframe credentials to log into that. When the data is flowing out of the out of the mainframe, then we have all the web interface and all our web part into the Kubernetes running on Linux. So this is our containerization strategy. So you have the alerting sites installed in there. So that's where it will be accessed by the operators, the web interface, and the real monitor. Now, when we are talking about the machine learning part, we also have some components that are installed inside the ZOS. So we have like data movers where we can pick up all the data coming out of SysView and we can move the data into the database. We can stream that and then the data will be processed and it will be presented also in read as part of a machine learning algorithm in the Kubernetes environment. So it is a combination of pieces that are deployed inside the ZOS with also components that are installed on the Kubernetes environment. Now, just to finish, so we also have a quote here from principal system programmer, Brad Dawson, about what we get is better dynamic alerting sites. So how we can really make sure that we not only get like reactive alerts, but we also have the ability to monitor environment, its behavior, having no single place, and get all this contextual data behind it. WatchTower Platform is being added as a value under the existing licenses for our customers on the SysView, NetMaster, OpsMVS, and Advantage. So they are all available for them to download and start using that. Any questions?
Not so much a question, but probably a question. So using that WatchTower interface, I can jump around all the alerts, but then get to the point where I know what the problem is, and it might be cancel that Kix region, restart MQ, whatever. I don't actually have to come out of WatchTower to do any of that. I don't need to go green screen. I can do it all within the UI, issue commands, got the audit trail. So you just drive everything through that UI.
Yes, exactly. So you would need to go to like the specific tool if you need to really do a complex deep dive analysis that will go more than the data that we are presenting into the platform. But if you are able to identify all the root causes just using the platform and take some actions, and you can do from there.
For all those actions I take are logged. So if it happens again in 3 months' time, I can look at the old, oh, that's the command I issued. Yeah, memory's not as good as it used to be.
You can do that. So we keep this audit trail that you will see all the commands that are issued, who issued the command, what was the result, and all of that. And on the top of that, also, if you had that problem happening again, inside the WatchTower, you can see, for example, like this same problem happened 15 times in the last 7 days. So you monitor the environment, and at the same time, you keep your eyes on the continuous improvement. And then you can give some ideas to the system programmer team, like, hey, this problem is happening many times. Can we try to do a permanent fix or create an automation for that? So that's how you combine real-time monitoring with continuous improvement.
Was this developed more for developers or sysprogs?
It is developed for level 1 operators and for sysprogs and system administrators.
I think the question I have is, this seems like is there any AI applied to this to kind of be more descriptive or diagnostic, as to, instead of having to hunt and peck and do like the normal, I understand it's all in one place instead of going to different tools. You have all of that information, but it's still in different screens and you're still having to hunt and peck for that information for what the root cause was as you're searching for that or whatever. So do you guys have something that does a more diagnostic or even descriptive view of all of the alerts and problem to give a head start to, okay, this is probably the problem, and then they can dive into it? Or is it all just reliant on the L1 having the knowledge of, oh, I've got to look at this and this is connected to this kind of thing?
So we try to create some profiles inside of the WatchTower that will automatically get all this information for you. So it is not on the operator's hand that they will connect all this information, get the information that they needed. So probably the automation expert in the expert domains, they will build those templates to make sure that the right data is collected when the problem happens. Like when it's related to the AI, for example, like recommendations, what you should do every time there's a problem. We don't have that into the current code, but this is something that is our roadmap to make sure that besides getting all the data for troubleshooting, we also can combine it to summarize that information, like what action you should take next time that this problem happens.
Okay. So right now you're just using the machine learning.
Yeah, the machine learning will really look for any kind of deviation or anomaly detection based on the behavior of the environment. So recommendations will probably come next.
Okay.
Thank you.
So the $50 million question, what, and I know there's no simple answer for this, but what kind of overhead? So I'm gonna spin up another container in my ZOS Alpha, and obviously activity, it's going to be different Alpha, but has anybody said, oh, it's I'm adding a significant overhead, or are we sort of almost unnoticeable, just sitting in the background doing our stuff?
It is minimal, because today we have customers like with Ops MVS rules already forwarding alerts and all the data to other places. So we can treat all this data that is flowing to the WatchTower platform as another endpoint when you are getting that information. So for all the customers that we are working with, we didn't have any kind of a feedback about the overhead consumption being very high.